A question like this is a typical examination question. Okay? So when you write your grade 10 maths paper at the end of the year or in the coming assessment on functions, if you are not asked to sketch, you can be given the sketch. And then you can be asked questions from the sketch. Okay? So you need to be ready for both ways. Right? Please, don't be intimidated by the diagram. Just know your key concepts. Know your key concepts. Right? I'm telling you from experience because I've had the privilege of going to the metric examination marking center and marking a question on functions. Okay, that's grade 12. What I saw, it was an indicator to me that a lot of learners have got a problem with this topic. But I'm trying my best to make it as easy as I can. Okay? I'm trying my best to make it as easy as I can. So you have got those two equations. You have the quadratic and the straight line. In most cases, the quadratic and the straight line are combined in one question. Okay? The linear function, because it is the basic function, it can be combined with any function. So you must be a master of the straight line. You must know it, not like on the surface, deeply. Okay? So the first question says, use the graphs and the information above to determine the following. Right? This is f of x, by the way. Okay, that's f of x. And this is also g of x. Okay, and both of them, the f of x is y, g of x is also y. Okay, I'm emphasizing that because from experience, the notation of functions, that is f of x, g of x, it confuses some learners. Some learners will never get it throughout that concept. They will never get it. Okay, after spending 3 years doing the subject, they will never get it. And the foundation starts now. Alright, so we've got those two functions, one quadratic, one linear. Now the first question says, use the graphs and the information above to determine the following. The coordinates of A and B. Now our coordinates of A and B, let me use another color. Doesn't want to be chosen. So you have point A, point B. Okay? Now, your knowledge of equations that you did in term 1 is required. Knowledge of solving a linear equation, quadratic equation. Those are concepts that now, even if I come to your house whilst you are fast asleep, I ask you, solve this quadratic equation, you should be able to do it straight away. Okay? If you can't, then you can have problems with this, because that's the foundation. So here we want to find the coordinates of A and B. Okay? There's the coordinates. Now, if you want to find the coordinates of A and B, first thing that you must ask yourself, what is the value of y here? What is the value of y there? Because the coordinates are going to be x values, and there's going to be a y value. But for you to do it, because we don't know the x value, okay? The x values are not given. So the best way is to say, what is y at that point? Okay? A few minutes ago, I told you that along the x-axis, the value of y is always 0. So y is 0 here, y is 0 there. At any point along the x-axis, y is 0. At any point along the y-axis, x is 0. Okay? Those are very important concepts that you need to be aware of. So, if I want to do that question, 11.1, first, I'm going to use my quadratic function to get the coordinates of A and B. And its equation is f of x equal to x squared minus 1. Okay? Remember, f of x is y. Okay? F of x is 1. So here, y is 0, y is 0. F of x is 0, f of x is 0. So where there is f of x, I'll put 0. Once I do that, you get an equation that you are familiar with from grade 9. Okay? That's a difference of two squares. So we have 0 equal to x minus 1 times x plus 1. Right? If you solve that, you will get x equal to 1 or x equal to minus 1. Okay? Right? So, for the quadratic function, you need to be a master of the quadratic equation. The quadratic equation, solving quadratic equations and analyzing the quadratic function are correlated. There's a relationship. That's why you do the quadratic equations first in term 1 to prepare you for this. Okay? So, it means at A, we already know that y is 0. So at A, it makes sense to say that at ax is negative 1 because this is the origin. To the left of the origin, x is negative. So x is going to be minus 1 and y is 0. And then at point B, x will be 1 and y is 0. And then you're done. You get your 3 marks. What?
Is the series back to 0?
The question says coordinates. So you must write the answer as ordered pairs. Remember, I did ordered pairs, grade 8 and 9. Don't say no. Don't say no. You did ordered pairs. By ordered pairs, we are saying you have an x value and a corresponding y value. Okay? You did that when you did function. You did flow diagrams and all the stuff, table values and so on. So if you've got an x value and a corresponding y value, if you write them as ordered pairs, you write them like that. So if a question is under function is saying determine the coordinates, means you need to find the x value and the corresponding what? Y value. If you write the x, that's not a coordinate. If you write the x only or the y only, that's not a coordinate. A coordinate is both an x value and a y value because the Cartesian plane is two-dimensional. Okay? The Cartesian plane is two-dimensional, so you need to have an x value and y value. Okay? Then 11.2. Point C. Point C is that. Now you can all see that point C is along the straight line. It means your knowledge of the straight line will be required. Now, what's the value of y here? That's the question that we need to get. Okay? Now, the value of x here is 0. Okay, because the point is along the y-axis. So x is what? Is 0. Now, that makes things easy. Since this equation is in the form y equal to mx plus c, you can substitute x equal to 0 and you get y equal to what? To 1. Which means the y-intercept is 1 here. Because our equation is given in the form y equal to mx plus c. So 11.2, it's 1 mark. Okay, you don't need to do any calculation if you really know your stuff. So at C, x is 0. You have to know that. That's a basic concept that you have to know that, okay, point C is along the y-axis, so x is what? Is 0. And what's the y value? It's here. It's positive 1. It's the y-intercept. Okay? So when you see the graph, don't be intimidated by the graph. Only thing that you have to do, make sure you know your concepts. Okay? So let's move on to the next question. The coordinates of D. The coordinates of D. Right? Now the coordinates of D is referring to this point. That's the point there. Okay? Now point D is a point such that the two functions, they intersect at that point. Now when two functions intersect, their values for x and values for y will be the same. Any two functions, if they intersect, means at that point, their values of x and y will be the same. So both of them have the same x value, both of them have the same y value. Okay? Now because of that, since we know that f of x is y, g of x is y, we can start by saying therefore f of x is equal to g of x at d. Because g of x is y, f of x is y. Okay? So my first step for 11.3 is to write f of x is equal to g of x at d. Okay? Remembering that this is y, that's also y. Remember I said at the point of intersection of the two graphs, their y values are the same, x values are the same. So it's better to equate the y values and then you can solve for the x. Okay? Our equation for f of x is x squared minus 1. For g of x, okay, it's x plus 1. They are given. So we are saying since the left-hand side of the two equations are the same, it means the right-hand sides are equal. Okay? That's why. So we are substituting f of x by x squared minus 1. G of x by x plus 1. When we get here, the rest is great, is term one way. Okay? The rest is term one way. So this becomes x squared minus x minus 2. Because if we take that positive one to the left, you get minus 2, you get 0. Then you need to solve this quadratic equation by factorization. So you get x minus 2 times x plus 1 equal to 0. So if you can't factorize, you are going to have problems. And you are going to have a double problem because you can't factorize, then at the same time you struggle to understand the graph itself. You will have more problems. Yes? These type of questions they require you to factorize. So this means x will be equal to 2 or x will be equal to minus 1. You have got two values of x. One of them is not correct. It has to be rejected. Okay? Because we want point D. At point D, there's only one x value. Okay? There's one x value. And I'm sure you can see that that point, that x value is there. So, and the origin is here. So the x value must be the positive of the two. Okay? So it means we reject this one. Therefore, x is equal to what? 2. Okay? I'm not done. The question is asking me to get the what? Coordinates. So I also need the y value. It's a common mistake from my experience that Elena will do it all the way like this and stop here. If you stop here, you haven't answered the question completely. Because the question is testing you on coordinates. So you need both an x and a y value. Okay, now to get the y value, you can substitute this x into f of x, or you can substitute into g of x. Both will give you the same answer. But I encourage you to substitute into the straight line because the straight line is the simplest of the two equations. Okay? So I'll write my straight line is g of x equal to x plus 1. Okay? I've got a video on function notation and all the stuff. You can watch it. If you use function notation, where there is x, you put 2. Where there is x, you put 2. So it will be g2. This is the same as y. So y is equal to g2 equal to 2 plus 1. Right? So this will give you g2 equal to 3. Therefore, at point D, x is 2 and y is 3. And then you are done. And you must use common sense. Okay? If you look at the graph, at this point here, that's the point where D, the y value there, it's above the x-axis. So it has to be positive. Okay? You have to use common sense. When you're answering questions on functions and graphs, always use common sense. Okay? So that's what you have. And let's move on to the range. Right. I think some of you last night were asked, one of you was asking me about this range, and I referred you, and I sent you a link of the video, and I sent a video on the domain and the range, so you need to watch that as well. Okay, and I did an exercise on domain and range. Okay, the range is the set of all the the set of all the y values. The range is the set of all the y values. The domain, which is the opposite of the range, is the set of all the x values. Now, those two concepts are very important moving forward. Right? Now, in term one, we did interval notation and we did set builder notation. We use those two notations to write the domain and the range. Okay? Now, your range, you need to identify the minimum value of y and the maximum value of y. Okay? So if the question asks you, what is the range? What must come into your mind? Okay, what is range? Range are the y values. What's the minimum value of y? Figure it out. What is the maximum? Figure it out. Then use your term one knowledge of interval notation to write the answer. Okay, so for our graph, okay, I thought there's a video on quadratic functions or the properties. The graph has a minimum turning point here, which means the minimum value of y is the value of y here. And the maximum value of y was these arrows point upwards. It means the maximum is positive infinity. So let's not worry about positive infinity. We need to know what is the value of y here. Okay? To get that value, we know that at this point here, x is 0. So if you go to your quadratic function here, when there is x there, you put 0. What will be the value of y here? Negative 1. Okay, so negative 1 is the minimum, but it must be included because it's on the graph. The positive infinity is not an exact value, so we don't include it. So when you write your answer for the range, okay, there are 3 notations that you can use. 3. You can use inequalities. Our minimum is -1, so we say it's less than or equal to y, but y is less than positive infinity. Okay? Or you can say, you can use square bracket, say y is an element. Since the -1 is included, you put -1, but the positive infinity is not included, you put circular bracket. Okay? Or you can use a third way, whereby you can say y is an element of real numbers, but, okay, but y starts from -1, inclusive. So you say y is greater than or equal to -1. So if you write any of these 3 for this question, they are all the same. So it's up to you to decide which one do you prefer among those. Okay? You have to decide now which one you prefer. But you need to know that the answer can be written in 3 forms. Range is the set of the y values. Range is the set of the y values. Okay? Range is the set of y values. Right? 11.5. Now 11.5 it says the length of RG if OH is 6 units and F lies on F and G lies on G. Okay? Now you have to go back. You don't want to go back to the graph. The length of RG OH is 6 units. Now, what are we supposed to determine? We are supposed to determine what? RG. Okay, we are supposed to determine RG. If OH is what? 6 units. Okay? This point is point R, and that's point what? Point G. So we want the length of RG. Okay, I'm sure you can see that R lies on what? On the quadratic function, which is F. Okay? And G, point G lies on the straight line. Okay? And if we extend from G to the x-axis, we end up having a perpendicular there, which means this line RH is perpendicular to the x-axis, which means RH is parallel to the y-axis. Okay? So if you want to get the length of RG, we need to know what is the y value at G, what is the y value at R. But we are told that OH is 6 units. Okay? Our OH is this. It's from here up to there. Okay? Common sense will tell you that if the length from here to there is 6 units, what will be the value of x at H? 6. What will be the value of x at G? 6. Because RH is parallel to the y-axis. What will be the value of x at R? 6. Okay? So we know the x value at R, we know the x value at what? At G, it's 6. So all we have to do is find the y value here, y value there, by substituting x equal to 6 into f of x equal to 6 into g of x. And then we subtract the two y values. Okay? But I'm going to do it this way. Okay, so 11.5, I'll say the length of RG will be given by f of x minus g of x. But the x must be 6 and the y must be 6. Okay? So, we substitute into the straight line. Remember, this one here is x squared minus 1. And that one there is x plus 1. So all we are doing is we are substituting x equal to 6 there. So it will be 6 squared minus 1 minus 6 plus 1. Okay, this will give you 35. And that one there will give you 7. So your answer will be 28 units. All I did was I substitute x into the quadratic function to get the y value, x into the straight line to get the y value at G. Then I subtracted them. This will be like your y max, y minimum. Y max, y minimum. Okay? And your answer has to be positive. Right? Let's just do the last one. Now the last one is a little bit tricky. Okay? But I'll try to make it as easy as possible. 11.6 says determine the values, okay, the values of x for which for which g of x is greater than f of x. Right, this is probably the first time to do a question like this. So I will try to make it as simple as possible. Since you now know that f of x is 1, g of x is 1, what this means is that we want values of x on the graph, on the Cartesian plane, such that the y values of the straight line, are greater than the y values of the quadratic. What is that interval? Such that the y values of the straight line are greater than the y values of the quadratic. That's what the question is asking. And the interval must be in terms of x. Okay, so we go back to the graph. Okay. Go back to the graph. Y values. Okay, now our critical points to get the solution are the x-intercept, y-intercept, also a point of intersection. So these 3 points are our critical points. Let me use, I don't know why this color is not one of each of them. That's one. So our critical points are this point, that point, that point, that point. Okay? We want values of x such that the y values for the straight line are greater than the y values for the quadratic function. What that means is, for the same interval, where are the y values of the straight line must be above those of the quadratic function. That's what it means. In which interval is the straight line above the quadratic? Remember, if the straight line is above the quadratic, it means y is greater. If the straight line is below the quadratic, means the y for the straight line is less. So if you look at this point to the left of this point, the straight line is below the quadratic. So that's an invalid interval. From here, going to the right, the straight line is now above the quadratic, which means the y values for the straight line are greater than the y values for the quadratic. I hope you are following. What are we trying to determine? The values of x such that g of x is greater than f of x. And we know that g of x is y, and that one is also y. So we can call this one y1, and that one we call it what? y2. Because they are two different functions. So we want values of x such that the y values for the straight line are greater than the y values for the quadratic, which means the graph for the straight line must be above that of the quadratic. So to the left of this point, the y values of the straight line are below. So that's an invalid interval. Can you stop that? Mr. Chuponda is not there. Right? Already with the microphone picked my voice up saying that. And I told you that you need to behave. So to the right of this point, the straight line is above, the quadratic is below. Up to this point. At this point, they become equal because it's a point of intersection. Also at this point, they are equal because it's a point of intersection. Y here is 0 for both graphs. Y here is equal to the value we got there for both graphs. Okay? Beyond this point, going that way, the quadratic function gets on top of the straight line. So our interval that we want is from here to there. But because we don't have an equal sign there, it means when you write our answer, we don't put the equal sign because we are not going to include the value of x here and the value of x there because of the question. It does not include, okay, the two endpoints. So our answer will be, what is the value of x here? It's what? It's -1. Okay? Yeah, and we got them there. It's -1. What is the value of x here? 6. Okay, we got it somewhere. 6. Okay. We got it somewhere. Where we saw where we equated. Should be here. What is the value of x there? This one here, 2. Okay. If you didn't get it right here, it means the last question of this question you won't get it right. Okay, so we have x equal to 2 and x equal to minus 1. So when you write the answer for this one, it will be minus 1 is less than x, and x is less than 2. Okay. So we have our minimum, our maximum. But both are not included. Why? Because at the point of intersection of the graphs, the y values are the same. So we cannot include the minus 1 in the problem.